In this video, we are going to learn binomial distribution. The following must hold in order to have a binomial distribution. First, each of n trials has two possible outcomes. The outcomes of interest is called a success, and the other outcome is called a failure. Second, each trial has same probability of success. The probability of a success is p, and the probability of a failure is 1 minus p. Last, there is a fixed number of trials, and the trials are independent. The result for one trial does not depend on the result of the other trials. The binomial random variable x is the number of success in n trials. X can be any number between 0 and n. Tree diagram for binomial distribution. First, assume you have three independent trials, and the two possible outcomes are success and failures. Let p equals probability of success, and 1 minus p as probability of failure. Second, draw a tree diagram to identify the possible outcomes and the probability of each outcome. Last, construct the probability distribution for the random variable x equals number of success. Here is how you can draw a tree diagram. First, you write the outcome of the first trial first. It will either be a success or failure. Next, you connect your starting point with the outcome of first trial. You write down the probability of success and the probability of failure in what we call branch. The black line is called branch. Then you write down the outcome of the second trial. So if the first outcome is success, there are two possible outcomes for the second trial. And so is for if the first outcome is failure, there are still two possible outcomes. Again, you want to write down the probability of the probability of a success and a failure. And you do the same for the third trial, and so on and so forth. The SSS stands for all three trials are success. So the probability that all three trials are success is p times p times p. The SSF stands for the first trial is success, second trial is success, last trial is failure. And this is the probability these three events happens in the same time and in this particular order. First trial is success, second trial is success, last trial is failure. The SFS stands for first trial is success, second trial is failure, last trial is success. And the probability of this combined result happens should be calculated in this way. And so on and so forth. You could interpret all those probabilities by yourself. After you complete the tree diagram, you can fill in the following table. First, what's the probability that we have 3 success and 0 failure? 3 success requires 3s. So the probability for the outcomes with 3s is p times p times p. And there is only one way to get 3 success. Next, the probability that we have 2 success and 1 failure. There are 3 ways to get 2 success, 1 failure. First, trial is success, second trial is failure, last trial is success, or fail, success, success. First trial is failure, second trial is success, last trial is success, or first trial is success, second trial is success, last trial is failure. Then we are looking for one success, two failures. There are also three possible combinations for one success, two failures. First trial is failure, second trial is failure, last trial is success, or success, failure, failure, or failure, success, failure. Last, we are looking for the possible of all three failure. So it will be F, F, and F. And the probability of three failure is this number. And there's only one possible combination for 3F. Last, P is raised to the power of number of success, or X equal number of success. And then y minus p is raised to the power of number of failure, or n minus number of success, or n minus x. Now you have all information you need to complete the probability distribution for discrete random variable x. You can compare this table with table from the last slide. Random variable x is number of success. You can see this table, these two tables are actually identical to each other. Here is the formula for binomial distribution. N here is number of independent trials. P here is probability of success. X here is number of success. And it can be actually they should be integers. Any integer between 0 and n means it could be 0, 1, and n. This is called n factorials. I'll give you a few examples. The 2 factorials equals 2 times 1. 1 factorial equals 1. 3 factorial equals 3 times 2 times 1. 4 factorials equals 4 times 3 times 1 times 2 times 1, and so on and so forth. A special case is the factorial of 0. It is defined as 1. This combination here gives you number of possible outcomes. This equation here equals the probability of each sequence. Note that all trials are given either probability p or 1 minus p. The binomial mean, mu, is defined as n times p. The standard deviation for binomial distribution, sigma, equals the square root of n times p times y minus p.